Hello everybody. In this video we are going to discuss one more detail about the solid particles or beds that are composed of solid particles, and this is what we call fluidization. Before discussing fluidization and what we mean by it and how this is helping, we need to discuss one or a couple of drawbacks that we have when dealing with fixed beds. As I mentioned before, in one of the or two of the main important applications of fixed beds are the catalysis and the adsorption. And in these two cases, we need a large area for either the reaction to happen or for the adsorption to take place. And let's consider consider this figure that we have here as part of a fixed bed. So we will notice here that there are parts, since the particles are stacked over each other, there are parts of the catalyst surface that are not exposed to the flow. They are confined between the two particles, for this particle and for this particle, and the same here, and here. These parts are not exposed to the flow, so they are not active when it comes to the reaction or to the adsorption. They're not active parts, although they have the active sites, or they contain the functional groups that can do the adsorption or the speed up the reaction, but they're not active. Besides that, there is one thing you need to know about the catalysts and the adsorbents, that they provide or one of the very big advantages of both is that they provide very large surface area for the reaction or for the adsorption, and this area is not the outer area that we see. The catalyst, and this is one of the steps of the synthesis of catalysts or for the adsorbents, is to produce a lot of very small pores in the catalyst. So this which looks like a sphere, it's not a sphere that is totally filled, or that's not totally solid. It contains a lot of very tiny micro and mesopores that provide much larger surface area than the external surface area, and it's too much, so that 1 gram of an adsorbent or a catalyst can provide an area of 1 soccer field. So this is like a huge surface area in just 1 gram. So when we have particles of a catalyst or an adsorbent like this, these parts that are confined between the two particles can be an entrance to a lot of pores. So we are losing, it's not just the external surface area, which might not seem to be a lot that we are missing here, but we are also missing a lot of area from the internal surface area. So this is one issue that we face when we deal with fixed beds. So in some applications, it's very important to increase the exposed surface area of the solids to the fluid. The second point has to do with the equations that we use to calculate the pressure drop, which is Ergen equation. So if we just take a close look here, you remember we said that this is the profile for the laminar part, the pressure drop for the laminar flow. This is the pressure drop for the turbulent flow. So if you see here the relation between the pressure drop and the velocity is either linear in the laminar flow or a parabolic relation, so it's to the power 2. The pressure drop is directly proportional to velocity power 2, which means that the pressure drop is very sensitive to the velocity. So if we operate the column at specific velocity and the velocity increases, then this will lead to a big increase in the pressure drop, and this is sometimes sometimes an issue when we deal or operate columns. Usually when you operate any process, one of the very big advantages of operating any process is to have it operating flexibly, meaning that the operation can still be fine, and there are no big changes in the output with any change in the input. So for the fixed bed, we don't have, or we lack this flexibility, that if the velocity changes because it's coming from another unit and the other unit is coming or providing the feed to this fixed bed with a specific velocity, and then something happened and the velocity changed, then this means that if the velocity increases, then the pressure drop through this bed will increase, and this leads to uh, or this increase, it will increase, but I mean the increase is high, so this increase will lead to issues in the operation, and it might ruin up the whole process. So we lack flexibility of operation when we deal with fixed beds. So one solution to these two problems is fluidization. So fluidization is simply that we operate the column the same way we operate in the fixed bed. The feed is going from the bottom to the top, yani down up, and with a specific velocity. But the difference is the value of this velocity. In the fixed bed, the velocity is not high enough to change the location of the particles. But in the fluidized beds, we have the fluid flowing from down to up, and it's flowing with velocity high enough to fluidize the particle, meaning that it's applying force on the particles to overcome the gravitational force. So the particles are in a state of kind of equilibrium. It's not falling down by gravity, and it's not flying by the gas that is pushing it upward. So this is what happens. So as we see here, the particles get separated far away from each other, and they are suspended in their place. We will understand why we call it fluidized bed shortly, but this state is called fluidization. And as you see the fluidized bed, you can easily see that the porosity here is much higher, and the particles are farther from each other, and the whole area now is exposed to the flow. So it's now solving the first issue that we mentioned. We will discuss the other issue, which is the pressure drop or the flexibility of the column in the next video, inshallah. But for now, let's just agree for this. So it's clear that there is a velocity that will lead to this fluidization. I mean, at low velocity nothing will happen, so the bed will operate as it is. And as we increase the velocity of flow, the fluidization will start. So what we will be focusing on in this part is to know how to calculate this minimum fluidization velocity. But I would take this video and the next video as an introduction to fluidization and understanding the main effects of the fluidization on the pressure drop and the porosity, and then we'll see how to calculate the minimum fluidization velocity. This video is a very, very interesting video. It shows it's a very simple setup actually. It's just two chambers. They're two transparent chambers. One of them is connected with this hose that is connected to a compressor, so it pushes air through this chamber. This chamber contains this bed of solid particles. It's like sand or any other solid particle, and the two chambers are separated by like a sheet of a solid sheet that has a very, very big number of small holes. And when this compressed air is flowing here, there will no place for this air to go except through these small pores to leave from the top chamber. So this is just to fluidize the bed. So we will see how the bed behaves before fluidization and after fluidization. So what we see here is the bed, and as you see, if you tilt the bed, nothing will happen. If you get some sand and put them on a surface and tilt the surface, there is no flow that will happen. And even in this case, even at large angles of inclination, nothing happens. Now we will see how the bed will behave when the airflow is let in. It will be totally different thing. You'd see here the bed is behaving as if it's liquid. Okay, now the particles are farther away from each other. There are no friction between the particles, so the particles are behaving like they are. If you look at this from far away, you might think it's water or it's a liquid, but it's actually a solid. And this is why we call it fluidization, because it behaves as a fluid. And now we will zoom in, and you see there are bubbles of air that are going through the solid bed as if it's a liquid. So this is solving the issue of and you would see I'm sorry, I forgot to mention this. You'd see how high the bed is now. I mean the volume of the bed, and you can see the volume of the bed here. So if you compare the two, you would see there is a big difference in the height. The height increases, and this height is because of the porosity that increased because of the spaces between the particles. So I hope this video clarifies the point. So I'm going to stop here, and next video will continue, inshallah. So I'll see you there.